Let's take a look at question number 2 of RACE-1 of the Secureum Bootcamp. And this question asks which of the following assertions are true without affecting the security posture of the contract. So let's get right into it. It says option A, the buy function does not need payable keyword. So let's take a quick look at the buy function. Here we have function buy, you pass in a desired amount of tokens and it is public and payable. And it says this function allows users to buy tokens. 1 ether gives you 10 tokens. So the payable function basically allows ether to be passed into this function. So what actually happens in the low level is that if you don't specify payable for a function, Solidity will automatically add code that checks if ether value has been sent to the function that is currently being executed, then revert. So actually, if you want to save gas, you actually can save gas by marking functions as payable, which is kind of contra-intuitive, because if you add more code in Solidity, you would think that it consumes more gas, but it actually is the other way around. By adding payable, this revert on value actually is removed from the code. So we could remove payable, but that would make the entire function pointless, because the point of the entire function is to buy tokens for ether. If we can't pay with ether, we can't buy tokens, so this entire function would be broken without the payable keyword. So it can't be option A, I would say. Next we have B, balances must be private. So if we look up here, we have a mapping address to uint, which is private balances. And now the question is, does balances really need to be private in order for this to be secure? Because the question asked without affecting the security posture of the contract. So could we change balances to something else other than private? I mean, yeah, we could. It doesn't really affect, and nothing is really affected by changing balances to something else. It could be public, and then people are able to query whether a specific address, which balance a specific address has. It doesn't really impact the security at all. It just makes it readable, which would be nice for some cases, I guess. So there is no problem with changing this to public, and therefore balances does not have to be private, and therefore B is also not correct. C says transfer can be external. Now if we look at the transfer function, it is currently public, and if you just search for transfer, we can see that transfer is nowhere called within the Secureum token itself, which means that we can just change transfer to external. It doesn't impact its security because it was already externally callable with public anyway. The only thing that changes by changing it to external is effectively that the internal functions would no longer be able to call the transfer function, basically. But nothing is calling the transfer function internally anyway, so there's no problem changing it to external. So transfer can be external. Yeah, can be external without affecting the security posture. Next we have save add can be public. So what is save add? We have the save add function here, which is pure internal, and basically it adds two uints with each other and it returns the result. But before it does that, it makes sure that the result isn't smaller than what you put in, because if the result is suddenly smaller than the components that you passed in to sum up, then it means that it has overflown, that it wrapped around. And that is possible here because we are dealing with Solidity 0.7. So integer overflows are still possible natively in this in this version because there's no protection here like in 0.8. And therefore we indeed do need a save add function. Usually you would use a library for this and not just put it into our code directly, like the save math library, for example, which has exactly this function basically. So the function itself is completely fine, and the question is, can we make this public without impacting security negatively? And the answer is, yeah, we could totally do it. It's a pure function. Most functions, arguably, if they don't change states, it doesn't really matter whether they're internal, external, they're probably just some sort of helper function. Is there any sense in making save add public? Not really. It would probably only bloat the contract with unnecessary code, because then the function selector becomes more large, because every time the contract is called, it needs to figure out which of the functions is being called. And the more functions are externally exposed, basically, the more ifs it has to do, like, is it this function or this function or this function? And it would probably make the function selector less efficient, and therefore would make the execution cost of this contract more expensive. So would it make sense in terms of guess to make it public or external? No, definitely not. But does it make it in any way less secure by doing that? No, we can do that without problem because it's a pure function. So C and D are correct in this case.